Hello, greetings everyone. It's George Leoniak here at New Geometry, and today I'm doing another new conversation, and I'm so grateful and excited to have Michael R. Evans here today. We're going to be talking about his work with the Trion-re, a little back history in terms of his work with space clusters, making these amazing toys back in the 70s and 80s. So it's just a real special guest, real treat to have you on here. Been at Sacred Geometry for 50 plus years. So real special opportunity. How are you doing today, Michael?
I'm doing great. Thank you, George.
Fantastic. Well, Michael and I have been in conversation a little while. My previous video I did started working with, starting to work with the curved geometries of the circular, and there's no straight lines in nature. And Michael will probably say that many times throughout today, but all of a sudden it really opened up a new way for me to start working with the form. So I'm just thrilled to have Michael on here and show off some of his work that he's been up to. You want to just hop right into the slideshow? Will that give you some talking points, or you do want to say a few more things before we switch over there?
You're the leader. I'll follow.
Okay. Let's jump on the slideshow, because Michael sent me probably, I don't know, almost 40 or 50 images that I tried to cram into about 19 slides. And we're going to start with this one with the Buckminster Fuller quote here, because Bucky was influential in Michael's start. So I just wanted to kind of have a little interview with Michael here, just about how he got started in this and how his interest kind of blossomed from some of the work with Buckminster Fuller and others.
Bucky was actually secondary in any of this. I had already gotten into space clusters and creating it, and we were both doing a show at the Museum of Science and Industry, and I was there, he was there, and we met, and I showed him what I was doing. And at the time, he said, if you're looking, look for the universal intersection, because with that, all things can be made. And Bucky was one of the most far out people that we've had in the last century.
Mm.
I will also say, this did not come out, this work came out of an experience. I didn't set out to find any of these things. It was like following a path and finding pearls along the way.
Yeah, that's amazing. What about following up on the universal connector? I imagine we'll get into some of that while we're.
Well, I think that's the job of the rest of the population, because I realized when I started getting into this curved geometry, curved space, I realized that it went on infinitely. And I couldn't go infinitely. It would take an infinite amount of people, all those monkeys typing on the typewriter, to come up with all the things that this really means and what it can really do by curving the line, by seeing nature in its true form.
So it sounds like you feel like you just kind of got started with it, but really opened up a doorway for others to kind of follow in, huh?
Well, that's why we made it a toy. That's why I made space clusters, because as a children's toy, yeah, they had no problem understanding curved space. They didn't have to relearn anything. You talk to anybody who's got a MD or initials behind their name, they make their living by knowing things. They're not interested in not knowing things.
Right.
Made it a children's toy, which just allowed them to get used to putting things together. And eventually, those children are now 58 years old.
Oh, that's amazing. And this is the space clusters in hand. They don't make them anymore, so I was lucky to snag a few sets on eBay. People could keep searching around, but it just basically has these long rods with this connector piece, with the triangular connector piece, and just a lot of creative options. I'm just having a blast with it. We'll show some more pictures of it in a sec, but I've just been making all sorts of curved geometries, and it really instructs you about the different forms as they would be straight lines, but in a totally different way that kind of
The
curves.
paragon of nature itself. Nature does not work in straight lines. There are no straight lines in nature. They're a
Mhm.
figment of our minds. And I'd like to also point out that I'm not selling space clusters, so this is not a sales pitch. This is just this is passing on information that has come to me from playing with them
Yeah.
over the years.
Well, what were you doing with space clusters back then? Because you told me a little bit. It just sounded like such an amazing story to hear about how you were on the road and Captain Cluster here. You want to describe a little
It all
bit?
started. It all started. I met this artist who brought another artist friend over to my house,
Mhm.
and he came into my house with a structure like this: the
Yeah.
space between three spheres. I've been showing you this for you
Yeah.
yet. And he brought this, but it was 3 times as big as this.
Hmm.
And he put paint on the face of the structure. And he went up to one of my walls and started rocking the structure around on the wall. And then he took it away, and I was videoing, not videoing, Super 8ing. Video hadn't been invented yet. I was Super 8ing this whole experience. And as I was looking through the lens, I saw this umbilical cord that went back and back into history. And then all of a sudden I realized this was a symbol that I was looking for, not even knowing I was looking for one.
Wow.
And it all began with playing with this structure, which you are playing with right now.
Did you ever reproduce that symbol that came out on the wall there? Did you reproduce that in a kind of make?
No, I never did. Something you could do later on today.
Okay, I might get to that. That sounds really fascinating. I'd love to see what that looked like, because it was just that curved surface that was rocking back and forth. And I mean,
Rocking back and turning it all around, and it was like the umbilical cord. Well, umbilical cord is a good place to start.
yeah,
When I cut the umbilical cord of my son, both my sons, I could see the physical connection to all things that ever were, as far back as umbilical cords go. So we know, not a leap of faith, but we know that everything is connected in the universe, and we are connected in the universe all the way back to the first cord. And that's what Space Cluster shows, how everything is connected.
Hmm.
So it's a spiritual journey as well as any other type of journey.
Oh, that's beautiful. I love that connection. And did you see when you were working with the kids, their curiosity and that relationship
What I
develop?
did was I went all around the United States, and I had demonstrators at all the department stores showing kids how if you take the rod and you stick it into the intersection, it'll be fun.
Yeah.
So yes, there was quite a bit of, and you had to take home. I gave everybody a chance to make something, and whatever they made, they had to take home with them.
Oh, that's
So
awesome.
we were giving them away as well as selling them at the same time. And some of the kids came up with some amazing things.
Yeah, I know. I feel like I'm just getting started, and I know, it's too bad. Like I'm saying, this is the original packaging. Well, this is from the 1974 edition. I love in the back how you say the makers of space clusters have purposely limited the examples of what can be made so as not to limit your own imagination. Do your own thing.
Thank you. Thank you.
Do your own
I-
thing. I was like, perfect. It just basically shows you four images of just how to get started, a couple images on the front, and you go to it and see what happens. Well, this is just some of you sent me a couple to work out on, and this was the icosahedron here, like an icosahedron with the 12 vertices from a few different views, and the octatrine. You had to come up with your own language to describe these curved surfaces. And
Well, these shapes were never described until I described them.
yeah.
And I was at the toy show in New York City, and one of the Edmund Scientific, Mr. Edmund, came up and saw my booth, and I had all sorts of different structures floating around in my booth. And he said, "Yeah, I've never seen geometry like that. What do you call those?" And I realized I was coming up with new geometry that had never been described before. And I started buying books on physics and geometry, and I couldn't find any of these images to find out what their names were or where they were in the lexicon of mathematics.
Mhm.
And I had to name a lot of these structures.
I guess what was, I mean, maybe we'll get to it later too, but how did it come about? I mean, you saw the rocking of that image. Is that really the start of space clusters for you when your friend kind of had that curved surface, or did you,
Yes,
that was it?
because
Yeah.
this is the intersection in 2D, actually. Those intersections are two of these heat sealed together, and the edges cut off so you can stick the rod into the edges.
Mm-hmm.
This is the basic of those images.
So you basically saw this right here, this little yellow.
Right, correct. That's
Yeah.
this cut off the edges, two pieces, a front and a back.
Yep. And then you could just put as many rods, you know, about 5 you can get in these, and then make all.
5 is depending on how strong you make the intersection,
Right.
and out of the material you use. I mean, if we were using aluminum or and rods and aluminum intersections, we could build some pretty strong structures, some pretty big ones.
Yeah, it's pretty cool. I've got a few more sets coming on the way, so my viewers will definitely see some more creative examples. I want to finish off this giant form that I was working on here, which is going to make that it'll make a dodecahedron like this when it's all done. This giant one here is going to turn into that. It's probably going to be about 6-7 feet in diameter. I'm thrilled. I can't wait to do it.
Well, it would make that even more spectacular is filling in the interior. That's what happened with Fuller. He did the geodesic dome.
Yeah.
I wanted to know, what did the inside of the hollow dome sphere look like?
Yes.
And that's when I started, when I left Bucky, I went home and started trying to make first I made a Bucky ball, 5s and 6s, and it had no strength. It was like a balloon with half the air out of it.
Yeah.
It didn't hold up. The interior wasn't described. So I just started building tetrahedrons, which I knew how to build. And I kept going and going and going and going till I saw the 5s and 6s being created.
Yeah.
And it was like going through the eye of a needle. My life changed at that moment. It was an experience of mystical experience.
Oh man, that's beautiful. We're going to be showing some of the images of that Micky Ball and the icosahedron, that truncated icosahedron that is talking about. One thing about this though is you sent me this icosahedron image right after I sent you this because of the connector pieces here. I was thinking what I'd love to do is build these icosahedrons off of these 12 faces and have them growing into the form. I bet you that would come up with something pretty unique. I'm just going to need space clusters.
Say it again. Infinite is infinite.
I need Space Clusters 2022 to come out to help me make these.
Well, someone's out there. I'll be more than happy to help.
All right, great. So this is the Micky Ball. That's, I guess this is probably part of the experience you were just kind of describing of working with, maybe this is probably a little more advanced, or was this a little further?
The lower left is 20. The lower left is 20 sets of 10 tetrahedrons going around the core. If they all go together, you'll get the Micky Ball.
So all these, what are they, like yellow colored end tip points? That's showing that when they all come together, it creates the inner core there. And that inner core is what? The icosahedron is truncated.
Correct. The inner core is the icosahedron. That's the center meridian with the 5s in the middle.
Yep.
That's like a slice of the sphere.
Oh, this one here. Oh, right in here, right?
That's 5 slices. Yeah, correct.
Yeah, so this one, you just want to explain that. So this is if you took this form, three-dimensional form, and kind of like cutting an apple, let's just say, and
Correct.
at the top, another chunk, there's the middle slice, and the bottom half, and then back to the bottom, the very bottom.
Well, it's difficult to see what the inside looks like from when it's completed, made full.
Mm-hmm.
So that's why I did the 5 slices so you can see the interior of the Micky Ball.
Mm-hmm. And now we're going to get into the Trion-re in the next slide. And that is what you're using here as this connector piece, right? Now, when did that come into play? It was after space clusters, I imagine, right?
Many years ago, I started making solid pieces,
Mm-hmm.
like you showed at the very beginning.
Yeah.
Let's see, where do we have the flats? Do we have the flats somewhere?
We'll be getting the solid pieces just like down here, like these,
Yeah, like those.
like these ones here, these solid
Yeah,
ones. Mhm.
correct. So I started putting those together.
Yeah.
And as I started putting them together, I saw the space between each one of them, which was the Trion-re, to go up to the number 6.
This one here.
There
Yep.
you go. The Trion-re came here. The phase theory of everything, Pumatse, he's a physicist and teacher.
Yeah.
This is the flower of life, but it's 3D.
Exactly. And that was the way I was supposed to introduce you. I completely forgot. That was a little inside joke. The man who turned the flower of life who we got here into the three-dimensional form is
I took the flower of life off the 2-dimensional plane.
Yeah, that's off 2D into 3D. And each of
Correct.
these Trion-res are these petal pieces that you see here.
And what you realize after you realize that it's an infinite amount of structures that can be built, and that the Trion-re is a regular polyhedron,
Mhm.
which they for 2,000 years they said there were only 5 regular polyhedrons, but this is the 6th regular polyhedron that's never been described as a regular polyhedra.
Mm.
And from this, I wanted to show how the one makes everything.
Mm.
And contained within that structure is the elemental thought, which is pattern recognition, because it goes together by itself. You can't not make it. As you keep making things, you'll find that they go together or they don't. And if they don't, you got to change the way you're going,
Mm-hmm.
because it creates its own patterns, which is always the same and totally different at the same time.
Mm.
And it's the ultimate space between things. And the ultimate space between things is where the information is contained. It may not have been an arc of wood. It may have been an arc of light. And that's what I think the Trion-re is light itself. And the reason why it hasn't been able to be described before is it's at the Planck length size. It's so small that they had to invent particle physics to try and explain it, because particle physics came out when they realized things were so small that they'd never be able to see them or be able to describe it. So they say, we'll call it a particle.
Mm-hmm.
Well, this defines the smallest possible geometric regular form.
Mm. Yeah, it's totally incredible, and how you were just led to discover that. It only has 2 vertices on either end, which is very unique, and then the curved surfaces, 3 curved surfaces, that kind of meet back together, almost, I guess, like a banana, I guess.
I'll tell you where I found it. Do we have the optic clusters on your sideboard, on your slides?
They're down towards the bottom here, yeah.
All right, let's go there.
Okay. That one. This one here is probably the one you're looking for. This one?
Right, okay.
Yeah.
So as I started maybe 15, 20 years after I came up with space clusters, I was still playing with the geometry. I was in art school at the time.
Mm-hmm.
And I started making these optic clusters, optic tetrahedrons,
Mm-hmm.
and following the space cluster idea of curved space.
Mm.
And then I started to see that within those, between each one was this empty space right there.
Yeah.
And I made that empty space into a physical space
Mhm.
and took it out and isolated the Trion-re because you could never see it before in straight lines. It didn't exist in straight lines.
Mhm.
So consequently, in our thinking, we could never find the original thought, pattern recognition, and how it's spread through the universe, how it creates everything in the universe is that one shape, that one breathing. And you have to remember, the universe is breathing. It's not static. Even in rocks, the rocks are inside the molecular structures moving.
Mm.
This is down at that point that's so small that it's so hard to comprehend.
Mm. And it's that space in between here that's the,
It's a Trion-re. It's the
yeah.
ultimate space between. It's a space between everything in the universe.
Yeah, and it's so easy to make. And you know, because it's really, let's just go back to this right here, this flower of life piece here. And it really, you know, this is the first shape, which are each of those optic ones that you said, why don't you make this? You were on the phone and you told me how to make it. Basically, it's this shape right here by just scoring the inside edges, and then it just folds right up. You make 4 of them, pop them together, and there you go. I mean, you have
3
it,
of them.
three of them, put them together, and you have it right in your hand, just like that. They just, petals overlap. It's totally,
Like figure number 9.
yeah. And then if you put a few more of these together, then all of a sudden that's this little curved space in between, this curve here. That's where that Trion-re is fitting right in there.
Correct.
So
And
that
you got
must
to
be,
remember, the Trion-re is spinning, contracting, and vibrating at all times. We are doing a static, frozen stop action of the Trion-re. That Trion-re is spinning in real life and contracting and expanding and breathing. It actually breathes.
mm,
You know, you've heard that expression that a butterfly powers the universe
yes, I
by
heard.
flapping its wings.
Yep.
Well, that's the same thing with the Trion-re. It's vibrating and spinning and twisting. There you go.
Yeah, maybe some of these images help convey the clusters of Trion-res, I guess, here on this kind of weaving the pattern together, making larger and
And
larger
remember,
clusters.
we're the size of those is 0.3201.
Mm-hmm.
It's a very incredible number to try and grasp in the mind, how small that is.
Mm.
And what you're looking at makes air,
Mm.
the structure of air. It's the structure of water. It's you could run your hand right through all that. And it'll all come back right back together again. It's flexible. It's breathing in, it's breathing out.
Yeah, and I guess so what you're describing really is kind of like when you cluster these together, which now we see as maybe a sphere, right? But that sphere is made up of all those little Trion-res that are the Planck length that you're describing, but it's all coming together to make larger and larger spherical objects that are clustering into larger objects, but they're just smaller and just little unit that you're describing.
Correct.
Yeah, totally amazing. And I know you have some animations that we're not going to play today, but those are probably at your website and a few other videos of your work at the Michael R. Evans, is it a .com, I believe, at your website. So there's a lot more material on this than we're covering here, especially animations of things like this where they probably this is moving and kind of coming together.
I show where how they all go together, and I do it without words.
Yeah.
Because this doesn't need to be translated into any language. This is understood by anyone. It's self-evident.
Mm-hmm. And I would say you probably would maybe say that working with your hands with the materials will transfer some sort of information by just working with the forms besides just the visuals too. At least you probably experienced that for yourself in working with it, right?
And when I built the sphere, the Micky Ball,
Yeah.
I realized that me and it were one.
Well, you can't get any more
When I
mystical.
was about 5 years old, I somehow I realized that whatever they were telling me didn't make sense to me.
Yeah.
Spare the rod, spoil the child. A child should be seen and not heard. The things like this that would go on and on. And I finally realized that I was on a mission to try and figure out what is my place in the universe? Who am I? Where am I? What part of me is it? And this was able to show me, it's like doing Zen.
Mm.
The whole idea of Zen is to lose yourself and become one with everything. Well, playing with space clusters and playing with all this geometry by actually doing it, not directing it, but doing it, not thinking about it, but doing it, you realize that you are it and it is you. If you go far enough, and you will. I've already, I've already warned you what's going to occur.
I'm having way too much fun over here discovering that I'm it. So let's check out this slide over here, which I thought was just really just phenomenal in terms of the way things are moving around in this and all the layers that are happening. So what is going on here?
I took 2 sheets of plexiglass, and I printed on the plexiglass. I printed on the plexiglass Trion-rays going in straight lines.
Yeah.
And I put them on top of a photography light, and I put them both on top of each other, and I would turn them to see all the different patterns that it would make. Just like in the Istanbul and the Egyptian and artistic.
Oh, so they're layered over top of one another and you're moving them over top.
Right.
So
And I just turn them into different ways and they make all these different patterns from the same thing.
yeah,
In other words, it's one thing making everything. That is when you realize that, then you realize the oneness of our being in this universe. That's what this shows us. That from one thing, all else can come out.
So you're really just kind of changing the perspective of how it's being viewed through, but it's all the same thing, but looks totally different in all this. You're getting 12 over here, you've got layers of 6, and then you've got this kind of straight line kind of connection. And it's all 2D there though, right? It's all just 2 sheets of plexiglass.
Right. And I have 100 more pictures like that.
Oh, I'm sure you just had way too much fun doing that.
I've had a lot of fun. That was part of the whole, I used to be a real estate broker. I used to be after I got in the military, I got into real estate. I was a developer. I was making lots and lots and lots and lots of money. And I realized that the only thing I would have at the end of my life is lots and lots of money and I wouldn't know anything more than I already knew.
Mm-hmm.
And I left that world and got into this, and I've had no regrets.
So yeah, you were probably exploring all this all kind of while you were in that world too, though, right? But it's kind of
that's when it came to me. It came to me when I was in that world, but it was also the path that led me out of it.
Yeah, nice.
You ever hear of Alan Watts?
Yes. Mm-hmm.
Well, a lot of the things that Alan Watts says in his dissertations follows this mathematical path.
Mm-hmm. So it's really getting the mind out of the way.
It's a philosophical geometry.
Yes.
It's the path to take you from thinking to realize what infinity really truly means. You got to really lose yourself to do that.
I think that's a big takeaway.
Well, you know, we know things, and that keeps us from knowing more.
Hmm.
You got to get to the point that you don't know, and every step you take is the first step ever taken in that space.
You're saying things that I can't even put words to. So it's you're bringing it right there. But how much? I guess a question about mathematics in your process of all this, because some people might think this is like very mathematical what you're doing. How much did that?
I never passed a math class in my life. The best I ever did was in high school, my sophomore year, I got a C in geometry. Otherwise, I failed every other math class to this day. Numbers change. To me, mathematics is good for figuring out how much you owe and how much you got coming in. And that number constantly changes. Math, you can make the numbers add up any way you want.
Mm-hmm.
And they're constantly, when the universe is in constant motion, spinning and turning, and you're trying to define something that's constantly spinning and turning and getting larger and smaller, what number do you pick?
Mm-hmm.
You pick the contracting number, the expanding number, the twisting number. They're constantly moving.
Mm-hmm.
So this doesn't have anything to do with the numbers. It is the numbers. That's a great page.
Yeah, I think this might follow it up. I started today looking at this image on the left and just reading through it, and I didn't notice this originally, but you had exhale, inhale, and rest at the top of this, and these categories of, and then you had perceived over here, but this is all the geometry that you've kind of come up with to the right, and this is what basically where sacred geometry is describing tetrahedrons, cubes, octahedron, and all the rest, the platonic solids. And now this is a geometry that you're describing that is got the exhale, inhale, and rest phases within it. And I was like, oh, that really makes a lot of sense. And I could see the Trion-re, how it's in this expansion and rest phase here, and then it's getting larger and smaller throughout that. It really gave me some insight.
Well, you know, according to Plato's regular solids, if you look up the definition, if Plato's regular solids, you have to have straight lines and flat surfaces.
Mm-hmm.
So for over 2,000 years, we've been dealing with a tetrahedron being straight edges and flat surfaces, when in reality, it's more than that. Because it's alive.
And you're building these models. I guess I didn't even realize I did a good job of putting this slide over here, because this is showing the three versions of the rest, and this is the inhale, and this is kind of the sloped in exhale tetrine phase there. So, you know, that Trion-re is really these edges right here, right? So that would, if
correct, that'd be the Trion-re turning to another point. So the edge is on the outside now instead of is in the center.
Exactly. So that's why you're saying it's spinning, because it's giving you really giving you the breath within that.
It's all of those things at the same time.
Right. All that at once. Yeah.
Yes.
Yeah, totally. Yeah. I mean, I think the way this came to me today, because like I said, I have to build this stuff. I have to work with it to understand it. And just before our interview earlier this morning, I was like, this is actually probably the first image you really ever shared with me, I think, besides seeing the Micky Ball and some of the other things.
That's where it all started, right there.
Yes. So describe this one to me a little, describe to the viewers a little bit more about what's happening with this.
Well, the artist that brought the original piece to me, which was it was the space between three balloons, also brought these pie pieces.
Yep.
These pizza pies. And he showed how if you, he was a package designer at Illinois Institute of Technology, and package designers have to learn how to make something from 2 dimensions to 3 dimensions.
Mm-hmm.
And so he knew about cutting on one edge and scoring on the other edge. So when you could fold it and it still hold together.
Mm-hmm.
So when Fuller came and tell you to a class there when he told everybody again, look for the universal intersection. Auerbach, his name was Bob Auerbach, went home, took 12 balloons and blew them up, tied them all together, and took plaster of Paris and started pushing the plaster of Paris in between the spheres of the balloon and hung it up. And after a while, it dried, and then the string broke and it hit the ground, and it opened up inside were all these dinosaur bones, curved spaces and intersections that come together and go apart. And he tried to figure out, well, how do I make those same geometry out of a flat piece of paper and make those same structures?
Yeah.
And that's what this is. That's what the flats are. The rendition of how, if you took the balloons and put the plaster of Paris, you'd come up with how to make them. And that was how the space clusters were made, because he was making these out of plastic. And after a while they would break. And he was stuck. He was stuck with the center. What do I do with the center? And he cut the edges off the center, stuck rods in it, and that's space clusters.
Yeah, well, that's an awesome story. And like I said, like you sent this to me a while. Today was the first day that I decided to work with it to understand this a little more. So what they all do is they share the same basic Trion-re shape, the flower petal, the edge, and they are, I only did up to 6 basically, because I can make a lot of forms out of those. And they're just gonna fit together, and you just score the edge and curve.
So you tell me how much do you think you could make? But you have in common from a nonagon to a tryon to a 3-sided figure, and they all have one thing in common: the cusp.
That's this is what you're calling the cusp here, right?
That's the cusp.
Yeah.
The reason it's called the cusp because it's on the edge.
Mm-hmm.
And the cusps all are the same, no matter if it's a 9 or a 3 or a 4 or a 5 or a 6, the cusps are all the same. So everything is related to everything else.
Mm-hmm.
The whole concept of from one comes many is in this geometry. Geometry is the philosophy of who we are and what the universe is. More so than mathematics, more so than numbers. Because you don't have to remember, all you got to do is, it's real simple.
Yeah, the basic way to start this was with the 3, starting with the flower of life piece. This is this piece right here that you can fold up to make this. And then you have to share that same edge with everything else. And so I'll just do my little show and tell. We're going to show Michael's solids here that he made in a minute. But I was like, oh, if I put the 4 and 3 together, I'll just come up with the cube octahedron, because those sharing that cusp all the way around, and that's going to be a change the edge, how this slopes, but that Trion-re that would fit in here would have a slightly different shape based on how it's overlapping. Here it gets a little larger, and I did the icosahedron with the pentagon faces and the 3-sided one with 5 and 3. So you could do 6 and 5, and you'd make the Micky Ball, the truncated icosahedron. Just so many possibilities with just overlapping these. And I never built anything like this till 2 hours ago. So I was just like, oh no, what's going to happen next?
I hope you have enough space to put it all.
Thankfully, I made them small enough that I think I could pack a lot of these into one place. So, I mean, that was just totally new way, because up till that point, primarily what I've been doing, except for my last videos, doing a bunch of, the straight edge form. Here's a comparison of the, cube octahedron, which many vector equilibrium, many people are familiar with, roughly the same size structure. Boy, look at those petals at that intersection. That just gives you a whole different feeling and understanding of this.
The elemental thought in the universe, the original thought, is pattern recognition, and it doesn't show in straight lines, only in what you're doing now.
Yeah, it's a lot to take in because I got a lot of straight line geometry around me. I mean, my viewers know, like, I've constructed nearly about everything you could out of Zoom tools.
Right.
And I'm like, okay, I keep coming back to the same form. Where do you go after you get to this? I mean, I've got gazillion forms that I've showed people different ways of putting it together. So this is a breath of fresh air, let's just say, to work with some different curved surfaces to see how they fit together. They take a little longer to make, but there's something in being transferred through the process of working with that curved shape that is hard to.
It's a lot more difficult to score a straight line or a curved line than a straight line.
Yes, definitely.
So that's one of the reasons why we still do straight lines. It's easier to draw with a ruler than it is a compass.
That's true. It's sometimes choosing the easy route is, can make you miss some of the richness too. Let's take a look at some of the ones you did, because you did this cube octahedron, triangles and square faces. Now I was like, how did you get this one? Because it looks like there's some more surface texture here. It looks like the Trion-rays even fit in that. It's different than what I did here, it looks like.
Of course, it fit in everything.
Yeah. So it's
there are no straight lines. End of story. So anything that you built with straight lines, a Trion-ray goes between the points.
Mm-hmm.
Or one side of it, because you don't, if it was a real Trion-ray that moved and was flexible, if you made it out of some sort of sponge material.
Yeah.
And then I've got a friend of mine, Eric Rankin, who made them out of styrofoam balls and pipe cleaners.
Mm-hmm.
So they would bend.
Mm-hmm.
That's what he did.
Mm.
Richard Nunez has done that too.
Yeah, I mean, look at some of the shapes you're coming up with, this flower lotus petal looking designs here, and you can all take those apart and reposition them. Yeah.
Can your viewers see this?
Yeah, you can see it. I could see it. Definitely. You could do some show and tell if you have at the end, so we could see some of that in a little larger too.
And I want to show you one thing.
What you got?
This is a Trion-ray.
Mm-hmm.
This is a laser. If the battery's good.
Maybe we should wait till you can show us. I'll remember at the end, because you're just a little rectangle on the side of my screen. I'm sure this might look
Okay, we'll wait till later.
We'll make a reminder note right here so we can see that in full screen, because it's
got it.
Going to be as cool than just the little window we have.
Awesome. Well, yeah, fine.
Yeah, because we're going to get into that in just a minute anyway, Michael. It's the last thing we're closing on anyway. Just a couple slides here. This is, right over near you, you're saying, or where you're somewhere in your home there.
Right there.
Right there. I just love this display here of all the forms in the front, all constructed that way, and just the optics that are in the back there, just really awesome. And we showed this one a little bit before. We talked about some of that, but you've done so much cool stuff with working with light too. Sacred geometry is often said to be the language of light, and I think you making these optic structures out of these and running light through them is really bringing that home in an amazing way. So what inspired you to do this? How did you get into optics and working with the glass?
I wanted to see, I was making the paper structures.
Yeah.
And I wanted to see what they'd look like if they were made of, if they were crystals.
Yeah.
What would happen? Since it was light, I
Hmm.
wanted to shoot light through it and see what it did.
Hmm. And this
Curiosity.
is, what's this one right here? I mean, that is amazing looking.
That changes, that's this.
Yeah.
Made in polyester.
Mhm.
And as I move it closer or further away from the light source, the center image changes.
That's so cool looking. That's amazing. That's and then these are just the close-ups of the individual of the,
Right.
I think, right? Yeah.
Right. Go down to the next one.
Yep.
10 or 15. Those
Um,
are just some of the, once what I would do is I'd put the optic structure on a turntable with lights coming through it, and then I would shoot spotlight through that, and then I was on a turntable, and as the turntable turned, all these different images would just, and these are just, it's infinite, it's infinite, it doesn't end of all the different things that it projects.
yeah.
I mean, you see in the bottom right, it looks like a little angel.
Yeah.
In the
Yeah.
middle bottom, it looks like an airplane.
Yeah.
Looks like the finger of God to me. Looks like a flower up in here. Looks
Yeah.
like a titty over here. Looks like a jellyfish over here.
Uh-huh.
It's all in the light.
I know. I love that. It's so cool. We have this slide. I was like, hey, is this an art installation over here that you had set up? You're like, no, that's my place.
Go to 16.
16. Yeah, I'm definitely going to get back to that here. That's the studio. That's your place. Yeah.
Right. And so this just shows a little bit of a light show that I would do. But I did I shot lasers through smoke, I had over 75 different lasers working.
Oh man, that's amazing.
It was a great show. It was as good as any laser show anywhere.
And it was in your own personal space just for you.
My own personal, all I had to do is flip a switch.
That sounds incredible. I thank you for showing us these pictures of your inside workplace, your studio, and just all the beautiful creative forms and full of light. And I'm just really thankful that we get to take an inside look at this. It's just amazing.
This kept me busy for quite some time.
I can see. Yes, definitely. And you said this quote before here. It seems like a big one that I often see here. Is if light is a solid, it can hold the thought. And
that thought is pattern recognition, because those all go together on their own terms.
yeah, so I think maybe a little more description on what you mean, because you probably maybe mean pattern recognition in different ways than people may take that. You know, is it more than visual? Is it more than just what you see? Is it deeper levels of pattern recognition? How did that come to you, that phrase?
It came to me when I found the Trion-re.
Mm-hmm.
I realized that was the one brick of the path. And if you wanted to follow the path, just follow the bricks.
Mm.
So I didn't direct where I was going. It directed me to follow.
I see what you're saying. So the pattern recognition was conveyed to you.
It was right. It knew what to do all by itself.
Yeah.
Without me saying, this is the way you should go, bend left, bend right, bend down, bend up.
Yeah.
It would either work or it wouldn't work.
I totally understand. Yeah, I think that's one thing.
Go together, or it wouldn't go together. And if
Yeah.
it wasn't going together, that means whatever I was doing had to be changed.
Mm-hmm. Yeah, I actually have one right here. This is a good point that I wanted to make. You know, I really enjoy working with these ohm tools, and we discussed it a little bit. Here's one of their little connector pieces.
Right.
This little thing will think for you. You know, it tells you where to go, what to do.
But it's limited.
It is limited over time. You had to come up with all this with no connector piece. You had to find what the connector was to
Correct.
work with all this. So
correct. And only one rod can come out of one hole in a zone.
Exactly. Yeah. So you can have a lot of creative experiences, and I love these. I mean, they tell me so much.
But there's a number that can be put to it.
Yeah. So
there's so many, and that's it.
Yes.
Not infinite.
So definitely, it definitely seems to be more like a stepping stone. But when you get into not having anything that tells you where to go, And you,
Zome was a great. I had a friend of mine that made a zillion structures out of Zome.
yeah,
I thought they were great. I was at toy shows with Zome,
yeah,
and I thought it was a great tool, but it was not what I was doing. It
yes.
didn't do what I was doing.
Yeah, and well, maybe it was just too ahead of
Got
its
it.
time. Maybe it was too difficult for people to understand maybe
No,
what to
it's
do
straight
with it.
lines and no flexibility. It wasn't alive.
Hmm.
It's a static construction.
Hmm.
It's, it's the Eiffel Tower. It's static. There's no flex,
Mm.
no flex.
Yeah.
It's got a curve.
Hmm.
Otherwise you're limited. You can only do so much.
Mm. Yeah, I mean, you're kind of touching on, I wanted to put this in here. I know you were saying some different things about this yesterday, but I put it in just in terms of this person in Da Vinci-like situation here, because I love thinking about sacred geometry and what it means, or geometry in general, for our own evolution, our own opening to greater levels of awareness, deeper understanding within ourselves, coming up with the discoveries that you were describing before about how you discover this is you. You know, how does this all play into that process? You can only speak for yourself, I imagine, but do you have any speculation about sacred
Well, I
geometry?
made a lot of Trion-res out of paper,
Yeah,
and I put them on a big table.
yeah,
And if the head is the cluster, the flats, the feet are the flats, they're triangles, curved triangles.
yeah.
And I put all the Trion-res together in a over Leonardo's, because Leonardo, he was far out. I've sat and talked with the Leonardo many times,
Mm.
and it was a way to show me as a Trion-re.
So you laid this out over the drawing.
I got an image I could find next time of what it was when I made it out of paper.
Hmm. Yeah, that's fantastic. Well, I think that
Robert Grant uses the Vitruvian Man quite a bit for his mathematics
exactly, yeah.
too, and this is another way of looking at it.
Yeah, it's very organic in what you're describing here. It really, and I also had this slide in here that kind of connects to just in the nature, you know? I mean, there's a curved line right there. I imagine you look at this and see the other half of the Trion-re in this.
Actually, not until you mentioned it.
I don't know. What did you do?
I knew that's exactly the view that I have right this second, looking behind my computer, is that view. And no, I did not think about it being one line of a Trion-re, but but I look at everything as Trion-re. So
Well, I don't know. It just came to me. It must have been all this.
yeah. No, that's where I am right now. That's why it's hard to get me off my hill.
Yeah. So I just wanted to also end a little bit with just your, you've got that nature connection, and the geometry came through it. Was that it? I mean, it seems to be an inspirational component to not working in straight lines, coming directly from your relationship to observing nature.
No,
Okay. How
nature was not, nature had nothing to do with it. I came to nature realizing that it's also part of what I'm doing.
okay. Gotcha. Yeah.
In other words, it wasn't nature that put me going forward. It was a backward look.
Yeah.
Oh yeah, that's it too.
Yeah.
I'm the tree. I'm the avocado.
So
I'm all of this. I'm the rainbow. I'm the sky. I'm the clouds.
Hmm.
And I could know that from the geometry that I've been involved with. It's not an imagination.
Mm-hmm.
It's a realization
Yeah.
that I am all of that. And that's my screen on my computer. That's my screenshot. So every time I open my computer, that's what I look at. And I'm sitting here right now looking at the same thing.
Beautiful. Well, it sounds like you had your epiphany and awakening and realization through working with this sacred geometry, this Trion-re, and all the paths that a discovery that has led you on to kind of bring you to that awareness that you are everything else.
It's the one thing that makes everything.
Mm-hmm.
It's a very spiritual experience.
I know, that's what you said to me when you said, well, hey, if you make this, you're going to have a spiritual experience with that if you start working with that.
Well, when you recognize yourself in the geometry and you realize what you truly are and how you're connected to everything else in the universe, you go back to that umbilical cord and know that you've always been. Think about that. Think about that umbilical cord. It has been physically connected to every umbilical cord there ever was. So how far back does it, there's no leap of faith. It's a physical continuation of all time. And that's what this was able to show me, to confirm that, to be the religious experience, spiritual experience that it's been. Because it explained everything I asked when I was 4 or 5. Who am I? Where am I from? What am I doing? Where am I going? It explained who I am, where I am, and how I got here. And whatever the next step is it is what it is.
Yeah, it doesn't sound like you have to think about that or too concerned about what that might be.
No, I know what it is. I know how it moves from one place to another. And when we decompose, it turns into gases, and those gases turn into air, and the air turns into fleet. You know, it's connected. It's all cool.
We're going to be seeing you in that rainbow then.
There you go. Next rainbow you see, just think of me.
I will be thinking of you when I see that.
Oh, by the way, it was Captain Cluster and
Yes.
Star Lady that went around the country.
Star Lady was in there too? Okay, I didn't know Star Lady and Captain Cluster. There we
That's
are.
my wife, Star Lady.
We will remember you in the
Well, when I'd go around the country when I was selling my space clusters, I'd attach them to helium balloons and I'd have space launches. I had my own space program with NASA.
That's amazing. It sounded like, I know we're going to diverge here, and I definitely want to have you be able to show some of the things, but it sounded like you did introduce your work to NASA and you tried to bring it into other.
In the very beginning, when I realized the extent of how far this went and how radically different from the straight line, square boxes thinking, that the things that you, I mean, if you really were smart and intelligent and knew how to do things, not like me, you could translate this information into making space, the space station.
Yeah.
You can, things go together in a better way. So I went to NASA, they said, well, that's very interesting, but we've already got plans for the future. I went to General Dynamics, who my godfather happened to be one of the largest stockholders of General Dynamics. And the only thing he said to me was, where did you go so wrong?
Oh,
so,
no.
So there was nowhere. I went to universities, went to creative playthings. We did a lot of great things with creative playthings. We set out just pieces with no package or anything else. When the kids would come in, they're just pieces and no explanation, and see how they figured things out. It was fascinating.
It sounds like an amazing story. I'm glad that we got to highlight some of those components and pieces of all the adventures you traveled on with this. And I think we did a really nice job of covering everything in here.
I think so.
You sent me. So thanks for sending all those images. Let's stop the share and take a look at anything you want to show us up close and personal at this point with the Trion-re. You were going to send the laser.
All right. Here's the proof positive. This is an optic Trion-re. I'm going to shoot a laser into one end.
Oh, and it lights up. Lift it up just a tad. Lift it up just a little higher, Michael. There you go. Oh, wow. It's going all the way down through the whole thing at the other end.
Because it's light.
That's incredible.
All the light has to do is touch this one edge, and it goes all the way to the other side.
At any angle you put it at.
Any angle. I'm shooting the laser.
Bring it up to, there you go. Yeah. Look at that. Yeah, you're going from in the other direction and it's lighting up the other end. You're shooting it that way.
Right, because it's light. That's how light works. It is what it is. It really is it. It's never been described before.
Mm.
It
Well,
never played with this. This doesn't exist in straight lines.
yeah.
Perceived in my diagram is showing the breathing regular polyhedra.
Mhm.
This is the equivalent of a straight line in today's thinking.
Mhm.
This is a straight line, but we can see it's not really.
Mhm. Yeah, fascinating. That's beautiful. Thank
That's
you.
when I knew. When I shot the laser through the edge and it came out the other side, there was nothing to think about.
Mhm.
It was a confirmation.
Yeah, look at that. That looks so neat. See it lighting up and reflecting through every face there it's going around. That's incredible.
So just think of guys that use optics and whatever the scientists that use optics, if they had different kinds of optics to use.
Mhm.
This optic doesn't exist.
Mm.
This is the only one you've ever seen, other than the ones you made yourself.
Mhm. Yeah, well, they don't have any like that yet, but you're certainly inspiring me to take things to another level and starting to work with light in that way too. Um, well, Michael, if you have anything else to share, you can certainly do so, or anything else you'd like to say, because I think we're probably going to wrap it up here in just a moment. I think we covered everything we've got. Anything that you want to have? I've asked all the questions I could think of.
I appreciate you appreciating what I've spent my life playing with.
Mhm.
It's been an incredible journey, and anyone who moves in that direction, I can only say, don't surrender, move forward.
Mm. Yeah, thank you. That's beautiful. And I really want to thank all the viewers for checking this video out. And big thanks to Michael for sharing all that work, which fascinating journey. And Michael R. Evans is the website. So check out
michaelrevans.com.
michael.com. He's got other videos to describe and YouTube. So you can look up more of his work.
Have you looked at any of my writings?
I didn't even know you had writings. So I have.
It's on the site. You might want to take a peek because it gives a little indication of what what I thought about as time went on.
You know, you're revealing at the end of the video that I didn't do enough homework on this before we got started.
We'll do another sometime.
Okay, that sounds fun. I'll do more reading because, I'm such a tactile type person. I needed to really build this stuff and start to understand how
We have a lot more in common than we realize.
I'm sure we do. I had to do this first, and now I'll do the reading, and it will make a lot more sense. Because if I read all that originally, I don't think it would land on me the way it will now.
Oh, it's not. It's. I have a science paper that I wrote on the Trion-re, which is in there. But I have other writings, which are philosophical writings of where my mind was at the time that I came up with the Micky Ball. I'll give you part of it. The pages of time have no place for my name. My deeds will soak into the soil as do the heaviest of rains, some to evaporate back to the heavens from which it came, and some to sink back to the earth where all things grow. Say, take me when the life, I want to ride the rapids of your waters. There's things like that.
Thank you, Michael. Oh, I love it. That's music to my ears.
Pleasure.
We're gonna stop with that. Thank you, viewers, and please, we'll probably do another one sometime. So subscribe.
Will this be on your website?
I'll put it on the website. I'll put it on the the New Geometers. New Geometers Facebook group, folks. Michael's sharing a lot more in there. I'm sharing stuff. So check out the Facebook group if you want to check that out. We're having a lot of fun over there. So
Well, I'd like to put it on my website as well. So I guess I'll be able to do that.
definitely, yeah, we'll be right on YouTube. So
All right, great.
okay, great, everybody. Thanks so much. Thanks again, Michael.
Thank you.
I'm just pausing it.